Hey guys, and welcome back to another lesson on factors. My name is Miss Danielson, and today we're looking at common factors. I hope you joined us for our previous lesson on finding factors and finding prime factors. If not, I'm linking that down in the description box below because that's going to come in really useful today. Let's get started. First of all, when we're looking for common factors and it seemed like we've got nothing in common, remember this orangutan and this dog. If they can find something in common, surely so can we. There is always a common factor. Remember that factors are the whole numbers which evenly divide a value without producing a decimal answer. So for example, the factors of 6 are 1, 2, 3, and 6. 6 divided by 1 is 6, 6 divided by 2 is 3, 6 divided by 3 is 2, and 6 divided by 6 is 1. Note that there is a limited number of factors for any given number, but all numbers have a common factor. Think about what that common factor might be. Common factors for two or more values are numbers that could possibly divide both of them. So for example, 18 divides by 6, that gives 3, and 48 divides by 6, that gives 8. Since both of these numbers can divide by 6, 6 is a common factor of 18 and 48. The highest common factor, however, is the highest factor that two or more values have in common. So for example, 18 and 48 can both be divided by 1. All numbers can divide by 1. They could both be divided by 2 because they're both even numbers. They could both be divided by 3. 18 divided by 3 is 6. 48 divided by 3 is 16. And they can both be divided by 6, as we've just shown. But if we're looking for the highest common factor, that's the biggest number of these shared factors, and that is 6. 6 is the highest common factor of 18 and 48. Now, in all of these examples I've given, I've just assumed that you knew the factors of 6, and I assumed you knew which numbers we could divide 18 and 48 by. But if you don't know what those factors are, you need to go back to what we learned in our previous lesson. That is, back to our factor spiders or our factor trees. Now, factor spiders, that's level 1 for finding factors, give us all of the factors of any given value. We pair those factors off symmetrically on the pairs of the spider's shoes. So when we start with the smallest factor, which is always 1, and we divide our value by that number, we get our biggest factor pair, which will always be the number itself. And then we work through the next smallest factor and we get the next biggest factor pair, and so on until we work our way to the middle, and then we know we have all of our factors. Now, generally, our year 7s just focus on the factor spiders. We get into our factor trees more with our year 8s and year 9s. However, it's a good idea to get started with that now because you'll see that factor trees and prime factors are really helpful when looking for the lowest common multiple or the highest common factor. Factor trees we could call a level 2 method of finding factors because it's a little bit more advanced, a little bit more sophisticated and helpful. Let's weigh the pros and cons of factor spiders and factor trees. Factor spiders find all of the factors, and if you pair them off nicely and neatly, as I've shown you in the previous lesson, you will end up with all of those factors from smallest to biggest as you work your way around the spider. Factor trees only find the prime factors, so you don't have all of the factors listed, just the smallest possible factors that you could break that value down to. However, we can combine these prime factors in all different possible ways to form all of the factors, and I'll show you some examples of that in a second. Factor spiders require us to be able to divide by all of the factors in order to find the factor pairs, while factor trees only require divisions by small prime factors, so it requires a little bit less mental calculation. Factor spiders are only used to find factors. It's very good at finding factors. However, factor trees can be used to find factors and multiples of a number. This is really interesting too, because I hope you're not confusing factors with multiples. However, we can use factors, particularly prime factors, to find multiples of a value. Another advantage for factor trees is we can use the prime factors that we find from the factor trees to express any value as a product of its prime factors. That is to say, we can write any value as a multiplication of its prime factors. Let's compare factor spiders and prime factor trees for the number 140. As a factor spider, we'll start by setting out our legs and we'll balance them off in pairs. The lowest factor of 140, the lowest factor of any number, is 1. And 140 divided by 1 gives us our highest factor pair, which is 140 itself. The next factor we should try is the next smallest number. So after 1 comes 2. Does 140 divide by 2? Yes, it does. 140 divided by 2 gives us 70. So we see the smaller factors are on the left-hand side, and we're working our way around, and our bigger factors is on our right-hand side, working our way around. The next smallest factor, 1, 2, we should try 3, but 140 does not divide by 3. So what's the next number that 140 does divide by? Does 140 divide by 4? Yes, it does. 140 divided by 4 is 35. Does 140 divide by 5? Yes, it does. 140 divided by 5 is 28. Does 140 divide by 6? No. In fact, we shouldn't even try 6 because 6 is a multiple of 3. If 140 can't divide by 3, it can't divide by any multiple of 3. So it can't divide by 6, but it can divide by 7. 140 divided by 7 is 20. Can it divide by 8? No, it can't divide by 8, but can it divide by 9? No. Can it divide by 10? Yes, divide by 10, that's 14. Can it divide by 11? No. 12? No. 13? No. Then we're done. I've got all of my lower factors and all of my bigger factors, and I've met here in the middle. There's no other factors to try. So my factors of 140 are 1, 2, 4, 5, 7, 10, 14, 20, 28, 35, 70, and 140, in order from smallest to biggest. So that's a factor spider. I found all of my factors, but I had to do quite a few difficult divisions in order to find them. Let's try a factor tree for 140 now. Now, if you're in year 7 and this is your first time seeing factor trees, don't worry too much about it. Just see what you can grasp from it, and we'll grow from that knowledge as we go through year 8 and year 9. If you're in year 8, you should really be testing yourself, pushing yourself to see if you can really take advantage of this skill. So starting with the number 140, and I'm going to branch off from there using only the prime factors. 140 divided by, what's the smallest prime number I can divide 140 by? 2 is the smallest prime number. Does 140 divide by 2? Yes, it does, and the answer is 70. Now 70 is not prime, so we're going to split that down into prime factors as well. What prime number, the smallest prime number, can we divide 70 by? Can we divide 70 by 2? Yes, we can, and that's 35. Now 35 is still not prime. Although it's not even, I can't divide it by 2, I can divide it by another prime number. It doesn't divide by 3, but it does divide by 5. 35 divided by 5 gives me 7, which is a prime number answer. So I can't split 7 down any smaller than that. The only numbers 7 can divide by are 1 and itself. So my prime factors of 140 are 2, 2, 5, and 7. So I could write that as a product of prime factors. 140 is 2 times 2 times 5 times 7. It's a nice way to check that you've done that correctly. And now if you look carefully at my prime factors of 140, there are nowhere near as many prime factors of 140 as there are factors of 140. However, all of these factors of 140 could be made up of a combination of the prime factors of 140. 2, I've got as a prime factor. 4 is 2 times 2. 5, I've got as a prime factor. 7, I've got as a prime factor. 10 is 2 times 5. 14 is 2 times 7. 20 is 2 times 2, which makes 4, times 5 makes 20. 28 is 2 times 2, which makes 4, times 7, that's 28. 35 is 5 times 7. 70 is 2 times 5, which is 10, times 7. And 140 is all of these multiplied together. So although I don't have all of the factors listed, all of those factors can be made up of the prime factors. Now, as I've said before, the factor trees are a higher level method of finding factors. So if you're struggling with that, don't worry about that too much right now. I'll keep showing you examples of it, and I hope that you'll start to understand a bit better. But let's start by using factor spiders again to find the highest common factor of 12, 54, and 20. For the factors of 12, we'll do a spider with 12 as the body, and we'll start with the smallest factor. 12 can divide by 1, and the answer is 12. The next smallest factor, after 1 comes 2, 12 can divide by 2, and the answer is 6. After 2 comes 3, 12 can divide by 3, and the answer is 4. And that's it. There's nothing more for me to try, because going in order from smallest to biggest, I've done 1, 2, 3, and going in order from biggest to smallest, I've gone 12, 6, 4, and we've met in the middle. There's nothing else left. So the factors of 12 are 1, 2, 3, 4, 6, and 12. As you see, I can write them in order, just looking in order going around my spider. Let's do that for factors of 54 now. So 54 is the body. The lowest possible factor of any number is 1. 54 divided by 1 is 54. Can I divide 54 by 2? Yes, I can, and that's 27. What about by 3? Yes, I can, and that's 18. What about by 4? No, we can't divide by 4. 5? No. 6? Yes, we can divide by 6. 54 divided by 6 is 9. How about 7? No. 8? No. Our next possible number is 9, and we've already got it. So we've got all of the factors of 54. In order, again, working our way around the spider, we've got 1, 2, 3, 6, 9, 18, 27, and 54. Let's do that for 20 now. 20 is the body of our spider. We can divide any number by 1, and the answer will be that number itself. So let's go on to 2 then. Does 20 divide by 2? Yes. 20 divided by 2 is 10. Does it divide by 3? No. Does it divide by 4? Yes. 20 divided by 4, and the answer is 5. So we've got all of our factors. Again, working our way around the spider. 1, 2, 4, 5, 10, and 20 are our factors of 20. But to find the highest common factor of these three numbers, we need to look at all of the factors of each of these numbers and decide which is the highest one they've all got in common. Well, the highest factor I see in all of these is 54, but it's not a common factor. The other two numbers do not have 54 as a factor. Next, I see 27, but the other two numbers do not have 27 as a factor. Next, I see 18, nope. 20, no, only in this one. 12, nope. 10, nope. 9, nope. The first match I see is 6. 6 is a factor of 12 and 54. And also 3 is a factor of 12 and 54. But 6 is not a factor of 20, so it's not a common factor for all three numbers. Let's keep looking for a match then. 4 is a factor of 12 and 20, but not of 54. However, 2 is a factor of all three numbers, and so is 1. Remember, all numbers can divide by 1, so we can always find a common factor, but we're looking for the highest common factor. And the highest factor that all three numbers have in common is 2. So the highest common factor of 12, 54, and 20 is 2. Now you're going to want to write this down. 1 is a common factor for all numbers. When you're asked for the common factor, don't automatically put 1. They are usually asking you for the highest common factor. We are almost never asked for the smallest common factor. In fact, if you were asked for the smallest common factor, they were probably trying to trick you. Now let's try factor trees for the same three numbers, just to show that there's more than one method to get the same answer. and then you can pick and choose which way you think is going to be easier or quicker or better for you. So to find the highest common factor by using factor trees, first, let's find the prime factors of these numbers and express these numbers as a product of their prime factors. That is, take their prime factors and show that they multiply together to give that number. Then find the highest common factor of 12, 54, and 20. By looking at the product of the prime factors, you should see what all three of the numbers could possibly be divided by. Starting with 12, I'll branch 12 off to its prime factors, first dividing by the smallest possible prime number. 12 divides by 2, and the answer is 6. But 6 is not prime, so we keep going. 6 divides by 2, and the answer is 3. 3 is prime, so we can stop there, and we can say that 12, as a product of its prime factors, is 2 times 2 times 3. Or you could write 2 squared times 3. 54 again, start with the 54, we'll branch it off. 54 divides by 2, and it gives 27. 27 is odd, but it is not prime. It still divides by 3. 3 is a prime number. The answer is 9. 9 is not a prime number though, so we need to keep going. 9 can still divide by 3, and the answer is 3. So now that we have a prime answer, we can write 54 as a product of its prime factors. That's 2 times 3 times 3 times 3. Notice I didn't need to multiply by 9 or 27 because I've got the 9 and 27 by doing 3 times 3 makes that 9, or 3 times 3 times 3 makes that 27. So we only need to write the number as a product of its prime factors, the ones we got circled at the ends of these branches. Let's do this for 20. So branching 20 off into its prime factors, 20 can divide by 2 and the answer is 10. 10's not prime though, so let's keep going. 10 can divide by 2 and the answer is 5. And 5 is prime. I can't think of anything to divide 5 by apart from 1 in itself. So we stop there and we say 20 is the same thing as 2 times 2 times 5. Now looking at these numbers written as a product of their prime factors, you should see what they've all got in common. This one's got 2 2's and a 3. This one's got a 2 and 3 3's. This one's got 2 2's and a 5. The most that they've all got in common is the 2. So the highest common factor, the biggest number we could divide all three of these numbers by, is 2. Same answer as we got the other way, just a different way of looking at it. There's slightly fewer divisions that we need to do this time, and we're only dividing by small prime numbers. So once you get the hang of it, I think factor trees tend to make things a lot easier. But if you prefer spiders for now, that's fine. We'll just keep going, showing you both ways so you always have the option. Now let's get on to some practice. For each of these sets of values, list all the factors, highlight the common factors, and identify the HCF, that is highest common factor. Okay, so if we need to list all of the factors, there I would recommend you use spiders, because by doing the spiders, you get all of the factors in order from smallest to biggest. Then you need to highlight the common factors. So looking at your list of factors, just highlight the ones that the values have in common. And then identify the highest common factor. Of the ones that you've highlighted, which one's the biggest? For question 2, I just need you to find the highest common factor of these sets of values. If you only need to find the highest common factor, you don't need all factors. You don't need to use the spiders. You can if you want to, but you might find, especially as some of these numbers are quite big, that factor trees will make this easier for you. You choose the method that works best for you. You don't have to use the same method for all questions, but hit pause now, give it a try, and hit play when you're ready to take up your answers. I hope you had a chance to hit pause because here come your answers. For question 1A, Those are all of my factors of 28 and all of my factors of 16. I see both numbers have 1, 2, and 4 as common factors, but of course the highest common factor is 4. For question B, those are all of the factors of 45 and 27. You can see that both of those numbers have 1, 3, and 9 as common factors, but the highest common factor for those two numbers is 9. For question C, we've got 3 sets of numbers this time. I've listed all of the factors of each of those numbers. You can see that all 3 of those numbers have 1, 2, and 3 as common factors, but 3 is the highest common factor that all 3 of these numbers share. Question D, there's all my factors, and all 3 of these numbers can be divided by 1 or by 3, but the highest common factor of all 3 numbers is 3. For question 2, as I suggested earlier, I think it's easier to use trees. So I started by expressing these numbers as products of their prime factors. So 88 is the same thing as 2 times 2 times 2 times 11. 2 times 2 is 4, times another 2 is 8, times 11 makes 88. And 68 is the same thing as 2 times 2 times 17. That's 4 times 17, that's 68. Now looking at these numbers written as a product of their prime factors, you should see that they've got 2 times 2 in common. 2 times 2 is 4. That means the highest common factor, the biggest number we can divide both 88 and 68 by, is 4. If you did this by listing out all of the factors, good for you. That was quite a lot of work. But if you did this by factor trees, you'll see that we get the same answer. Question B, again, writing these numbers as a product of prime factors. 148 is the same thing as 2 times 2 times 37. 37 is a prime number. It's a big one, but it is prime. And 76 is the same as 2 times 2 times 19. Again, another big prime number. Both of these numbers, when we write them as a product of their prime factors, they both have 2 times 2. That means both of these numbers can be divided by 4. Again, the highest common factor is 4. Question C, again, as a product of prime factors, we see that all 3 of these values have 2 times 2 times 2 as parts of their product of their prime factors. That means all 3 of these numbers could be divided by 2 times 2 is 4, times another 2, that's 8. The highest common factor is 8. And question D, as a product of prime factors, notice they all have 11 in common here. HCF 11. Now, how did you manage with that? I'd be curious to know who prefers using factor spiders and who prefers using factor trees. If you need another lesson on factor trees, please have a look in the description box down below so you can get a bit more practice of that in. If you manage quite well with that, maybe you'd like to try a bonus question. Use common factors to simplify this fraction. Remember that to simplify a fraction, we need to divide both the numerator, that's the top number, and the denominator, that's the bottom number, by the same value. See if you can work out what that highest common factor is, and leave me a comment down in the comment section if you think you got the answer. Let me know if you had any trouble. Otherwise, till next time, keep practicing, and I'll see you soon.